Good morning, everybody. Thanks for being here. Who was here last year at the Tampa location? Anybody? So we got one or just a few. So if you were here last year, this is a continuation basically of the presentation that was there for all of you that are new. My name is Shay Griffin. I'm with Trimble Navigation, and I'm from the Civil Engineering and Construction Division, which is basically the heavy civil dirt guys, but within that dirt division we have a marine division. And what we do specifically is marine construction. And what we're going to do is kind of show you what we see as the trends of technology to benefit what you guys do and what you do every day. And so what we're going to do is we're going to walk through the technology, show you what's going on. After this presentation, starting at 3 o'clock, there are time slots available to go onto one of our boats from Measutronics to kind of show you the technology as it occurs and see how that might benefit you in the line of business that you do. Who knows? Anybody do Army Corps contracts at all? Okay, so just recently, if you're doing any type of dredge contracts with Army Corps, there's a requirement there called DQM. We're qualified to do that now. That just came available, so if that was part of your business. But what we'll do is we'll get started and show you what we got going on. What we've done is, unfortunately today, our friends from Teledyne couldn't be here because they're setting up for a conference in San Diego this very weekend. They're located here in Daytona Beach. And so we partnered with them on the sonar side and software side of what they do to enhance what we do on the above water side. So what that boils down and means is that Trimble, we're from the GPS and positioning side of the world. We do the navigation on the GPS side, and that's eyes above the water, whereas you have Teledyne, they're the eyes below the water. And this isn't new technology. Many of us know about sonar systems and things of that nature. However, it has direct impact on your business now because we're applying tools and tool sets to what you do on a daily basis to benefit you. I hate to say it, but a lot of the dirt guys, they've been the beneficiaries of the early technology. Even back into the early 2000s, the question was, why would you put a bulldozer, why would you put GPS on a bulldozer? Now they don't do grades without that. And nobody touches the machine without some sort of technology on the machine. Lagging behind that is us. But now we have the advantage of taking, the ability to take advantage of new technologies that could help you in your business and if you want to try and grow that. So here's the idea of what we're talking about. From our perspective, from the Civil Engineering and Construction Division, we put together kits for a multitude of different applications. This is just giving you an example of what we're doing. In combination with the sonar, you see the sonar sweep here, you're going to have your high and low spots as there's in this particular example, we're talking about a cutter suction. We make it so the operator has basically a stoplight, right? Red, green, and blue, or however you want to do it. So we can tell the operator, has he made grade? Has he gone over grade, under grade? Where is he at? High and low spots. Same principle applies to the excavator. If you're doing any type of excavator dredge work, the operator is going to be able to see the marks as to where the bucket's been. Because once that device goes underwater, I hate to say it's almost like a Helen Keller method type of technology where, before in the past you're just hunting and pecking, trying to figure out where you're at. Now you're going to have the ability to actually zero in where you're supposed to be and do the work that you have to get done. And if you think about it, this is for your protection, because you can go back and say, yeah, I did the work, I have reports right here, and you can prove it based on what you see here in these images. Anything that you see here for the operator is the ability for them to validate the work that's been done. Or you come back and say, oh, you didn't get a spot, or you didn't do this. You can validate that you did do it, and also give me a check because I need to get paid. That's what it boils down to. So I'm going to hand it off to Trevor real quick here. He's going to kind of continue from the Measutronics side. They implement our solutions as a channel partner, and also take into account the Teledyne side of the business. They work with that side of the business as well.
Thanks, Shay. So I'm Trevor Yoakum with Measutronics.
Yeah, I'm sorry. You got it? Sorry about that. Go ahead.
Cool. So Measutronics, we're actually right down the road, right down I-4 in Lakeland, Florida. We don't do a lot of our actual production work there. We do a lot with heavy machinery like excavators, dredges, pile drivers. No one's going to bring their excavator to Lakeland to get work done. So we cover a big footprint, and it's in a very niche market. And it's all marine-based, and we deal with hydrographers, marine contractors, dredgers, Army Corps, and a typical sales cycle would be right there in the middle. They call us with a problem. We use a lot of similar components to solve all these problems, but the same problem, we never get the same problem twice. But we design a system, make sure they know what it's capable of, and then we sell it to them, install it, support it, train the operators. When it comes to this software, there's not too many people right now in the country who are using it, but so we take on a lot of that support, but it runs pretty well too. So we started in '97. The owner, Lee Nash, who was originally supposed to be here today, found it off the back of his truck in Lakeland, Florida. He was just doing GPS surveying, and that's kind of transformed when he went into the hydrographic field and the construction field, and kind of brought them together. We sell equipment from what we think are only the top of the line vendors. A lot of our systems, it's in real heavy construction, so you really don't want to go cheap on a sensor and have it break on you. Downtime is always more expensive than capital. We incorporate a lot of our solutions together. As I said, we serve hydrographers on the sonar side, but we also incorporate sonar into some of these construction solutions. That's some of what you'll see today if you take a ride out there on the boat.
Speaking of which, on the logistics side, we'll have a couple of trucks shuttling people down there, so to get you there on time, try to be, if you're scheduled at top of the hour or below the hour, maybe like 20 minutes before, because it's about a 10-minute ride, so we'll get you down there in time enough to switch out and get you on the boat for the demo.
These are some of our partners. Teledyne, like you said, down the road. They do a lot of stuff on the water and under the water. Trimble and Atlantics give us our positioning. And you may notice some other of these vendors if you guys work in the marine industry. Like I said, we have a large footprint for a small company. I was hired 3.5 years ago, and I'm the 8th person there, and that includes the boss and his wife. So, like I said, we travel all over the place, a lot of it in the islands, the Caribbean, Central America, a whole bunch of stuff on the East Coast. We just opened an office on the West Coast in Vancouver, Washington, right near Portland, so we can start serving that area as well. So we cover a pretty broad range in the marine construction industry. From a lot of it is dredging. I think I only saw one guy raise their hand for Army Corps.
Yeah, who does dredging work? Any dredge?
Yeah.
Okay, what about on the marine construction side? It could be piling, local piling, things of that nature. Anything on the hydrographic side? Okay, so it's a bit of a mix. Okay,
Yeah,
so we kind of touch all areas of these applications because the technology kind of traverses these applications, and that's kind of what their job is as implementers of the technology.
Yeah.
It's one thing to sell it, it's another one to support it and sell it and implement it and to help you out. So.
Yeah, and so we use the same software for all these applications. It's very diverse, very flexible. But yeah, all these different type of dredges we've worked with. In the marine construction, especially the pile driving, we've done several pretty niche jobs we'll talk about, wick drains, and then the hydrographic survey. Some of the projects we've worked on over the years, bridge moves, dry docks, wick drains, pile drivers, bunch of dredging, tug and barge guidance, really anything that you would need to put a GPS on something, we've probably worked on it. So the boat that you're going on today is near the top there. Do you know if they're doing LiDAR and sonar, or is it just the sonar?
Just the sonar.
Okay. Well, we do this really cool thing with LiDAR as well. If you guys aren't familiar with it, it's a laser scanner that just spins real fast, gets you a highly dense point cloud. So we have that set up going over the side that the same way our sonar is pointed, and we can get a full above and below water 3D point cloud. It's really cool. It's pretty extensively used in bridge inspections, pipeline inspections that are right there at the water line. It's just more of a cool look, though, than
They had a cool project,
anything.
the D-Day project. Anybody have family that served in World War II? Anybody? Did anybody serve on the beaches of D-Day? No? Yeah? Okay. So just recently, they were tasked to go out with TV crew, and I think they basically were able to map out every lost tank and piece of equipment. I don't know if you've seen this episode. I think it was on PBS. But those were the guys, Measutronics were the guys that helped put that together for that program. So that's kind of the extensive background that these guys have in terms of the marine industry. But anyway, go ahead.
Yeah, that was a really cool project. It was fortunately before my time, but if you see, it's the D-Day Sunken Secrets. Very cool if you're into that type of history. So to go into the technology more in depth, as Shay alluded to, we like to call it eyes above and below water. As you guys know, working on the water is just, when you can't see anything what you're doing, if it's under the water at all. And so that's what a lot of our systems are meant to make up for, is to be able to tell what's down there, or whether we're actually looking at it with sonar or other systems. So our partners enable us to do that. I mean, we design the systems, but we don't program. We're not coders. We don't make the program. We don't design the sensors. We give input. It's usually listened to, but so we work with wick drains here, clamshell dredges, dredging or dropping material, rock placement, cutter heads, excavators, pile drivers.
The yellow circles are where my company lives. That's the equipment that we bring to the table.
Yeah, they're bringing the sensors, everything for those machines to have their own guidance.
Yep.
When it comes to using this technology and marine guidance in general, you need two things. You need to know where you are, and you need to know where the job is. So knowing where you are, where the machine is, and specifically where the tool is, that's what Trimble takes care of. Their machine systems, wiring harness, all that. Gives us that. And then Teledyne, our imaging software, gives us what's going on below. A lot of these dredge surveys, you have to know what you're digging into before you go on the job. One, so you can appropriately bid the job, and two, so you can make sure you get paid after the job. So combining the two, we'll show some examples later, but we actually use sonars on construction barges while dredging, while placing rocks, to really give us that real-time update to stay as efficient as possible. She's not in here, but she introduced us at the beginning and was talking about technology making you more efficient. That's exactly what it does. You know the work that you're doing, you can do the work faster, and you know that the work is done when you're at the end. And that's what these two systems together really help us nail down.
Just real quick, as most of the work that you do, are you doing a lot of bid works for local municipalities or entities, ports, construction folks, bid responses? Are you starting to get bid responses that require some sort of technology to be used at all? So we're seeing that too. That's kind of what we're seeing as well. Yes, sir.
We're seeing it in one project in Fort St. Joe where they require aerial mapping.
Okay, so yeah, so that's kind of what the LiDAR that he was discussing, the point clouds coming from that. But anyway, this is just an example of what we're starting to see as well from the customers who are going to ask you guys as the contractors to have some sort of technology to implement on your system. So that's what we're hearing and seeing as well. Go ahead.
So part of that technology is sonars. I believe this might be the unit you see today. It's on a, you see that it's not pointed straight down like your typical survey is. It's at an angle. It's on a mechanical driven pan and tilt mechanism that you can aim down, up, left and right if you need to really make sure, one, that you're getting the whole area that you want. But you know, if you're looking for objects or...
But you're not going to be surprised by anything.
Yeah.
So if you're doing underwater work and who knows if there's a communications line underneath, something to be there that you weren't aware of, that protects you as the contractor doing the work as well.
Yeah, we had a scan we did recently where there was a sunken ship. They're about to be doing some piling, and there's a sunken ship that they didn't know about. And we're about to drive some piles right through it, and that, you know, could have damaged the pile, could have damaged the pile driver, could have been unsafe. Nothing would have happened, but it's something that they really needed to know. You know, I guess once it came out that they knew, they definitely got to take care of it. But so I'm going to go over a couple of these systems real quick. So we'll start with the GPS positioning. That brings us into the world, the pitch and roll, and some measurements. Takes us to the boom pin. We put a bunch of sensors on the arms, some more measurements, some more math. We make sure that these sensors are in these really thick stainless steel enclosures. And all of that, we get to the bucket tip using the software. And so now we can position that, you know, within centimeters, its location when it's working. We found this useful for mainly dredging. The software is made by the Dutch. They love dredging. They're good at it. But with their help and some of Trimble's help, we've really been able to use it for a lot of different applications. Especially using excavators. There's a lot of excavators out there.
What you're seeing here is us being able to take advantage of what the dirt guys have had for a very long time. They have this equipment on their machines. They can get it down to fine grade when they're doing their work, or even topo work, things of that nature. We have that advantage now on the marine side, which is really good for us because you know that anytime you get on water, everything's harder, regardless of what they get into. The dirt guys think they got it pretty good, and they do, because they can see everything. But when you enter your world, it's totally different. And so now we get to take advantage of the equipment that these guys bring to the table, which is really good for us.
You don't get a tiny rope. There's no stakes. You know, you're lucky if you got some buoys that are pretty close. But so with the dredging, this would be a typical display that you'd see. Talking about the stoplight. It's not blue.
Right.
Red,
yeah, red, green,
and yellow. But yeah, I mean, they've got a paintbrush and they're just trying to get to a certain, and I mean, this is all highly customizable.
Yeah, his day starts out green and he knows that he's got to get to red by the end of the day and his job's done. If he's got any other colors in there, he goes back in and tidies it up before he leaves and he's done.
Yeah, we show all sorts of information in there.
Here's an example of the...
This is the in-cab display?
That's the in-cab display. It's on it, so we typically would put it on a computer, sometimes a tablet, depending on the space. Some smaller machines have real small cabs.
So you can see here the bottom is what the operator sees in terms of where the teeth of the bucket are. Up top is where the middle section is kind of a topographic view, kind of overhead view. And then up above is kind of the 3D model view. Typically, the operator is looking at the bottom one because he knows he's getting to grade and he has his thresholds already set. So based on what he sees there, then of course...
Yeah, you have a design, you can have over and under dredge values in there. Let's put the red and... Let's play it again. You'll see red and green lines over and under dredge. I think I see a question.
Is the Trimble brand software that runs this called Teledyne? I thought it was called HydroPro.
HydroPro's the old version. That's kind of going away. That was from the 1990s. And we found ourselves in a position as Trimble that we needed to complement what HydroPro used to do, but also we needed 3D modeling for what the operators need to see, but also taking into account the sonar imaging that you guys have now as a tool in your toolbox. So we partnered with Teledyne. So they're the ones who have the software. We partner with them locally here, and we put these systems together to make it one unit type of response.
Do you support both at Measutronics?
Yes, yeah, you probably did see some old HydroPro screenshots in there. That's what I was raised on, but yeah, it was 2 years ago.
Correct.
2.5 years ago.
Yep.
Trimble and Teledyne. Trimble really wanted to upgrade their marine construction software, and teamed up with Teledyne to rebrand Teledyne PDS, which is what you'll be seeing on the boat today, and which is why the sonars work so well with this construction application, is because it's basically made by the same manufacturer. So yeah, it's Teledyne PDS rebranded as TMC, which comes with a bunch of different applications. If you were to buy PDS, I'm not going to go into the sales stuff, but it's functionally similar. So with that, the excavators, we've had to support a bunch of different attachments, clamshells, orange peels. These were some shears, jackhammers. This one's really cool, the jackhammer.
We're going to show you a video kind of enhancing what you're seeing here, but this is real data coming from the Tappan Zee Bridge. You can see here, he's got to zero in and take down these caissons. And so he knows exactly where he needs to be, and he's basically resolving to the size of a caisson that's this big and hammering it down. And he knows exactly where to go back in to pick that stuff up and get the debris taken care of. It's my understanding, I did get clarification on this, but I think they budgeted about 2 years to clean up the old bridge across the Hudson for this project. They're now chasing performance bonus because they're way ahead of schedule.
Yeah.
So just because of what they've been able to implement from this technology, they're going to knock it out of the park for the performance budget. And if you know in your line of business, if you're getting the performance budget, you're ahead of schedule, you're doing well. That's a good thing to get. So
yeah, I don't know how many of you guys are familiar with the Tappan Zee Bridge project. It's been going on the last 4 or 5 years. American Bridge, Fluor, some other guys, they all did a joint collaboration. But I mean, it's like a $4 billion project. When we came to them, they said they didn't have any money for this type of technology. We really pursued it, and then the first order came with 5 excavators, a crane, and a sonar vessel. And so this data that you see in there is from the sonar vessel. They now have like 10 excavator systems, a couple of cranes, and that survey vessel is supporting all of them. He goes around, does scans on demand. They transfer that scan directly into the project here. And so what I really like about this this video, being on the tech side of it, one of the guys that sets this up, is that down here, when the tip of the tooth, or the tip of the hammer is right there on the surface, I mean, it's right there. That's what he's feeling, that's what he's hitting. And if that positioning were off, I mean, it'd be to the side, it would be a little higher, or it'd be cutting in all the time too much. But it's like right on there. And so
towards the end of the presentation, we're going to show you a live video of this happening. So it's actually kind of cool.
Yeah, I mean, basically the live video is just
doing
underwater.
the sonar scan. How much processing happens between that scan and the guy in the cab being able
With these guys, they don't process it at all. They'll process it when they start doing final reports, but they're doing this every day. So they're not going to spend the time processing it. The data comes in pretty clean with just some filters, and
it goes right from the survey boat to the cab?
Yep. They have industrial Wi-Fi set up, and they just log in basically through TeamViewer and
So he gets updates as he goes through and does his work.
yeah. So when the barge thinks that they're done, they're ready to go, they call up the survey boat. He comes, does a scan.
Because it's like, you should be able to get done with this today, I expect you to be here tomorrow. And they're knocking it out of the park.
So
Yeah.
it's, I mean, that was right there at the birth of TMC when that project came around. So it really helped sell it to other people.
So this is our wire crane setup. You know, you got the bucket, the digging sheaves, and then you have the positioning along with your the drums, the sensors for the drums. Lateral anger sensor, you can talk about more.
So what we're basically measuring here is where the tip of the bucket is, just like with the excavator. So we start with boom tip positioning. The second one for heading of the machine in general, because we're doing 3D. We try and visualize where the boom is, just in case they have functions of object avoidance. So if there are overhead power lines or a bridge that you don't want to swing into, that can be programmed in there. There's a lot of functionalities that I won't talk about that it can help with, like that object avoidance. So we track the location, the horizontal location with the GPS. We have these rotational encoders on the drums that give us our verticality and also our open and close on the bucket. Again, all made possible from the software. This is an example screen video of what they're looking at. This is, again, out of Tappan Zee. You can see on the left side some of the really how
Like the bucket marks.
yeah, well, and so you got the bucket marks, but you can see that the sonar scan is very detailed. I mean, so they're demolishing a bridge. I mean, so there's crap everywhere, and so it's picking up all those things, and that's what they're trying to grab. There's all the crap down there.
And due to environmental requirements on the Hudson, they had to remove every piece of the old, the old wooden piers and the icebreakers and things of that nature. They had to totally take out the whole thing and smooth it out.
Yeah, it was built in the 50s, so it's old. More clamshell dredging. This one uses the 3D a little bit more extensively. If you notice in the 3D view, when you close this bucket, there's still a little mound there, and that's how tight we're measuring these buckets and how accurate the sensors are.
One of the operators wanted to see bucket marks, so we gave him bucket marks.
So
Okay, that's fine. You can have bucket marks.
it's a high-pack thing. So this is bringing the software, the two technologies together. This is barge-mounted multi-beam on one of those pan and tilt mechanisms. This was actually, I believe, the caisson that they were hammering on in the video earlier.
Yeah, you can see the upper section there, that 90-degree section, that's where the caisson is.
Yeah.
Exactly where they need to be then on that.
So they're trying to, so they're checking to see if they've gone down low enough per their requirements. Pile driving system, we're typically positioning the leads. It's very hard to position the pile. You can't put GPS on a pile and you're about to hammer it. So we put 2 GPS on the leads with a pitch and roll sensor, and we measure to the pile center. TMC can handle battered piles if that's what the design calls for. The piling function was actually designed for the project that's in this video. They're up in Canada, but it took about 2 weeks of me going back and forth with PDS to develop everything that we had liked from HydroPro and its piling, but taking advantage of their 3D functionality. And so the operator, he's just trying to put one needle on top of the other, and when they have, you can see the design, I mean, they're very clumped together. I think these are wood piles. They got a lot of different angles. They can only approach it from a certain angle. So having all that, the operator being able to see that, I mean, one, it saved them boatloads of time. They went from doing 2 to 3 a day to doing like 12 a day. And then
The Army Corps?
I'm working on it. I forgot where else I was going with that. But yeah, I mean the pile driving, it's gotten a lot safer. They had a couple of guys out there on this like floating dock that they just like kind of rotted their way out there, and we're trying to use a GPS rover and line, and it wasn't a good deal. So they're loving it. And so, as I said earlier, with the traditional piling GPS, we're only really measuring where the leads are and not where the pile is. Well, we developed a system last year where they really wanted to get the inaccuracy of the muck in the gates, what's holding the piles there, because we measure to where we think the pile is going to be, but it's not always in the same spot. So to actively measure the pile, we put distance range lasers at 2 different points on the leads. The software did a best fit circle of each of those points, and so they were able to measure inclination from it, the exact location, and they had their requirements where they had like 6 inches of tolerance over 4 piles. These things were massive, and they were able to get there. They were definitely ahead of schedule.
Yep.
And I believe they're about done now with all of it. So this is a video of their setup. On the bottom here we have the lasers. You can see it, maybe you can see it. It's kind of hard to see, but there's little green dots that shows that the laser's showing up. There's one not showing up, but he's ignored because he's not within the expected pile area. They're actually using multiple GPS because they're having a hard time keeping fixed in pile driving. With GPS, I mean, you're creating your own obstacles with the leads right there, the piles right there, your barge, your crane, boom. A lot of that does affect GPS. So they threw 4 of them on there, and we were able to use all 4 simultaneously to best fit or least squared position the leads. This was one from earlier this year up in Memphis. They were tracking a bridge. This actually wasn't marine-based, but they needed the software and the flexibility that it offers to position where the bridge is. So you have basically the green bridge on top is where the bridge actually is. That's what we had 5 different total stations with prisms on the bridge, and they basically hiked it up on roller skates and very slowly moved it over to where the new bridge was going to be. And this was a process of like 6 hours, and they're only going 35 feet, so they're going real slow. They need to make sure that there's not a lot of twisting and turning in the bridge. So they put total stations on there, and it's just something that the software can do a lot of stuff.
So these are a couple of videos we're going to show you, kind of ties it all together for you.
My name is Lonnie Land. I'm the training director for Local 701. Today we hosted a tech day with Nash-Measutronics, Teledyne, and Trimble. I'm excited about where this is going to go. I know it's going to change the industry forever, and I think that it's really critical that we get ahead of this. We at Trimble have always been focused on land and what we can see. And now that we're into the marine dredging and some of the marine construction, there's a whole different world underwater where the contractor is basically flying blind. So Teledyne brings us a whole new perspective where we can now see what we're digging, where we're digging, what we have done, and to get it right.
The biggest benefit for the Trimble Teledyne integrated systems is getting it right the first time. To be able to see a real-time point cloud of of objects and the seabed. Really provides a lot of benefit to the operators to be able to see what's down there, where they can't see normally, they just see dark water. So it eliminates the having to go back and fix stuff, which can be very costly.
That's our West Coast guy.
See the power driving in action and to watch it in 3D and in real time on a computer screen remotely. So it's amazing. I think that the technology will increase efficiency and productivity through just taking an inexperienced operator and making him so much more proficient. And then having a really experienced operator, you give him this technology and there's just nothing he can't get. Teledyne sonar is probably the best in the world. The clarity, the vision that you get to see, I need to have details and I need to have it in real time. And that's what Teledyne sonar does. It is eyes below the water.
So one thing that they mentioned in there that I thought I'd touch on was the remote connectivity. It's not something I had talked about earlier, but with the way wireless connections are these days, I mean, cell internet is pretty good. And so, we typically will have a cell modem with every system, and that's how we can provide the support to all these systems across the world, or at least across the Americas, without, killing our time and taking up all our time traveling on site. We can log in, look at it right there most of the time, at least diagnose the issue or solve it.
So here's the video going back to that hammer that we saw on the caisson. This is kind of giving you an overview of how that came together.
There we go. So that's obviously the old bridge. Fun fact is they had to blow that one up.
We have machine control positioning, accuracy with GPS that we've never had before. So the system is going to change everything. Underwater, using this equipment is completely amazing.
He's from Palatka.
Using Teledyne gives you the ability to have a complete solutions partner.
So we take the best of the best, we're able to integrate them, merge them together, and give the customer the best solution possible.
So that's the sonar you're going to see today. They're using the same one that's on our boat.
That performing in water demolition is very familiar with the term working in the blind. That's basically what people do. It's faster, it's easier, things that you missed as you go through the area, you can get a pinpoint location on, you don't have to look around for things, you know where everything is. I've been able to resolve images as small as football-sized pieces of concrete. It's worth spending the money on the system. It's got to pay for itself within the first job, and it's the future.
So that's pretty much it.
Where we see things going, based on what you've seen here thus far, is there any of this that you think would benefit what you do in your line of work each and every day? Let me ask you that question. Because I think from from a bidder's perspective going into and going after projects and whatnot, you got to know your costs. Your ROI is where you're going to be, your savings with efficiencies and things of that nature. And in the case of the Tappan Zee guys, they're going after performance bonuses where they didn't think they were even going to be there. That's just some of the benefit that they've witnessed amongst other things, you know, crew scheduling, safety. They found a cable wire that was underneath for communications. Imagine if they had hit that. Who knows what that was tied to. But anyway, so you can kind of see the idea. That's where we see things going as Trimble and Teledyne in combination with your industry. And we're committed to that, what you guys do every day. That's what my job is, to benefit you guys. So we'd love to see you out on the boat. The sign-up's out there. Probably about maybe 20 minutes in advance of your time frame. Try and be out front. We'll get you down there and get you ready to get onto the boat. My card and Trevor's cards are up here in case you'd like to ask us more questions. We'll catch us right afterwards or whatever. Any questions?
Yeah. How well does this scale down? And what I'm doing here, in the last 8 years, I've permitted about 30,000 yards of dredging on small creeks, and it's mostly environmental dredging. This is not about navigation. So I'm starting out in shallow water, trees overhead, canopy, tight conditions. They just finished off 7,000 yards of one project for us with a small hydraulic dredge, 6-inch line.
Yep.
And I did all of the permit work. We did it with a mixture of electronics. And what we find out is when we get into the edges under the trees, the data disappears.
Correct.
We supplemented all that data with me and a canoe and a tape and a rod. And I do a lot of that under these really tight conditions, and that's what it's for. And I'm looking at what you're doing, and it would be awesome to be able to run that kind of system, but how shallow can it work? That's one thing. Does it tell me what my bottom is?
Yes.
Per se?
I mean, in terms of the makeup of the bottom?
Well, one of the
Material
things we
makeup?
ran into in this last project, and this was one of those chance observations, as they ran through and it was in an open area, and they did the electronics, come back in with the data says it's foot deep. I thought that's a great place to take a core sample. Went out and dropped a 10-foot piece of PVC, and it just went wham, straight on down. What I had was an old creek alignment that was changed by a canal, and the way that they changed it over the years, that canal dumped into it pointing upstream, and it etched this long trough. Since that has then filled up with organics, and that's what was happening, was a 10-foot layer of organics. I could push a 1-inch piece of PVC through out of a 10-foot canoe and extract it and stay dry.
So from the Teledyne perspective, and correct me if I'm wrong, they have what they call sub-bottom profilers, which gives you the material makeup, if I'm not...
Yeah, it uses a lower frequency, so it cuts through muck until it gets down to the bottom. 10 feet sounds like a lot, but I mean, I don't see why it wouldn't cut through till it gets to something that shoots it back up, which is, really hard surface.
Getting back to your point of shallow areas.
Shallow and confined overhead.
And of course, with overhead, you're going to have multipath, which your GPS is not going to do very well with because of the foliage or the canopy effect.
So to solve that, you got to have an elevation source somewhere. Typically, if you're using GPS, you want to use some sort of base station for RTK corrections. But most of the time, you're trying to do it using cell service, well, it's not really much of the cell service. But when you get that multipath, you lose your RTK, and your elevations go out the door. So to solve that, you can have a tide gauge that the software...
Elevations haven't been that much of a problem. What we're running into, and it seems to go in waves of things, in the last 2 months, we've had 2 projects that needed layout through mangroves. One was a boardwalk for a municipal park, and the other is a cut connecting the canal system to a natural creek itself. And when the crew went out to try and operate, even with a 30-foot rod putting the sensor up in the canopy, we were getting poor data at best.
Right.
But we had set up a protocol of, well, the first thing you're going to do is clear a center line, and we'll come out and remeasure. And then we corrected our offset, so we didn't get too far out.
Right.
But I'm seeing poor reception when we're near the mangroves, and I don't know if it's leaf interference or what I'm dealing with,
Well, you're going to have a
And the other
canopy
side of that
effect, yeah.
experience is about once a month, it seems like the GPS system here is down. And I had
Are you-
Oh,
you're
the DOT?
that I can't answer. I'm not the GPS.
It's probably the
operator.
DOT.
I'm a
Yeah, that's what I'm
data guy.
saying. Yeah.
You know, the only thing that stops me.
We've heard about that too. It's the state operations.
Yeah.
Actually, that went down last week.
I had an actual surveyor outfit on a project the other day when they showed up because I can't make their numbers work in my methodology. And we were going to measure it jointly to see where the error was. And they said the system was down. I said, how often does that happen? He said, no more than once a month. I said, my crew must be perfect at timing.
Yeah. Well, part of getting through the challenge of GPS sometimes with the foliage and overhanging and multipath and things of that nature is what he was describing was the tie gauge, and also, if it's even possible, a total station could be used, and that would solve some
Yeah,
of those
but
problems.
around all those trees, you know, once it,
All depends on where you can place the total station, if you can. Question?
or comment.
I've seen them use the land road for Trimble side, the R10s, I think.
Yeah, the
Where they
R10s.
have the
Yeah,
tilt sensor built in.
that's correct.
They
Yeah.
actually have the same setup with the rotor with the antenna on top and the bottom. Trimble makes it where you can pitch it in any direction and it'll calculate the distance. So you can stick like a 30-foot rod into the mangrove at the bottom and base of the mangrove, the antenna's way out
Yeah.
in space. And it'll,
Yeah, we
where
actually,
you don't have to hold.
That's,
that just came out as wicked stuff. I've never seen that before. It's called a tilt compensator, yeah.
It might not, and they're expensive.
Also, when you're doing shallow creeks like that, something to be aware of is when you want to get the materials of what you're getting into, that's a sub-bottom profile. That's not really archery, that's Teledyne, but they can help you with that. But the other side of that is understanding where you're grading to if you need to do that. The UAVs from Teledyne, the little boats, can do the survey for you. You just run a mission with it, and it'll give you the data and update as you go.
Again, that requires GPS.
In some cases, yeah.
I'm trying to figure out where the cutoff is. Where do I become effective with the old school methodologies?
Sure. No, that's
Where do I know I'm going to turn the
Yeah.
GPSs?
absolutely.
Every picture that you showed me today, with one exception, had no overhead clutter.
you know,
Yep.
it's by design.
Yeah.
And we do those projects.
Yeah, you're the tough environment. That's the
tough.
challenge. Yeah, there's no doubt about it. So,
One other comment. There's 3 board members here, and we have a board meeting 3:30 to 4:30,
yes, sir.
and we're all signed up for your tour.
Okay,
So it's going to be like 4:30, and we want to go.
no problem. We'll get you down
That
there.
20-minute lag means you might be running late today.
No, that's no problem. We're gonna have delays in between, so we're set up to take you guys out there and make it happen. So, not a problem. So the gentlemen they're setting up, I think, if not soon, is Keith and Chesson. They'll be on the boat with you guys, and I don't know if you're sticking around. You're sticking around.
Probably not.
So he'll be here for a little bit if you want to have some detailed questions you want to get into it, because he's really the marine engineer, not me. So if you have any questions, we're here, and thank you for your time. Appreciate it.
Yes, thank you.
All right.
All right, well, we got a break now for lunch. The next